So far, any question about the crystallization topic? Okay. So now today, let's see how we want to produce crystal. What are the steps that involve in the process of crystallization to produce crystal? I saw some of the group's assignment in Enmodo. Some of you have turned in. I think the deadline already passed. Okay. By right, all of you, but last night I just managed to see a few. Most of you choose emulsion and foam. Yeah? I don't know how many of the groups here choose crystallization. I have not seen one yet. You choose crystallization. Oh, okay. So how do you find it? Or at least what is your experience when you do this kind of assignment? But one thing for sure, you have to think really hard about the topic, right? You have to go deep and try to understand and try to figure out what is the best way to demonstrate. That actually made you think. That's what I wanted from this. So basically, there are 4 important steps in the process in crystallization. Okay. The prasyarat, the prerequisite. One is, okay, remember, crystallization, the starting material can be a solution. Solution means if we have, let's say, sugar, which is a solute. We dissolve in a solvent, let's say water. So you have sugar in water, dissolved in water. So that is a solution. So we can start from a solution, or we can start from what? A MELT, from a melt. Okay, something in the form of melt. For example, chocolate liquid, fat, yeah, liquid fat, liquid oil. Those are solution. Those are, we use the term melt. They are in a melted form. So we can start a process of crystallization from a solution or from a melt. If we start from a solution, the solution must be in a supersaturated state. We will see how do we get the supersaturated state. So the first requirement for crystallization is a generation of supersaturated state. Supersaturated state refers to a solution, not to a melt. Okay? Go back again. For a melt, we have to create not supersaturated, we have to create a supercooling or supercool state. That's the difference. Yeah? Now, when we get to the supersaturated state, then the first point where the crystals start to form a nucleus. Yeah. So the process of nucleation, the formation of crystalline lattice structure from solution or from melt. Lattice structure, remember, yeah, the unit in the crystal. Then, just like when the baby form, not baby yet, you know, in the womb, what do you call that? Then it will grow. Yeah, it will grow bigger and bigger. So similarly, the crystal will start to grow. So there is a growth, growing and propagate. Growth and propagation. Yeah, growth and propagate. Growing lah. Subsequent growth of nuclei until equilibrium is attained. Until equilibrium is attained. most systems, they are not in equilibrium. They are not in thermodynamic equilibrium. Every system in the universe, they want to achieve equilibrium state. Yeah? They want to achieve equilibrium state. When we create a supersaturated solution or super cool melt, they are in a non-equilibrium state. Okay? So in order to achieve equilibrium state, they have to be in the form that is thermodynamically in a equilibrium thermodynamically, yeah, which is in the crystalline form. So the idea of nucleation and growth and finally form a crystal so that it will achieve the equilibrium state. Recrystallization is actually not really the step in crystallization. The main step in crystallization stops at the growth, but we can also get this phenomenon of recrystallization when the if the system has not reached the equilibrium, or if the crystal has melted and recrystallized. Yeah? So this the process of recrystallization, which is a reorganization of the crystalline structure to a lower energy state, generally without any further change in the amount of crystalline phase volume. So basically what happens during recrystallization is the rearrangement of the molecules in the crystal, but there is no change in the amount of crystal. That's the meaning of without any further change in the amount of crystalline phase volume, but it's just rearrangement of the molecules in the crystal. From alpha we get to beta, beta to beta prime. Yeah? So when we compare alpha, beta and beta prime, they are in a different equilibrium state. So they want to achieve the most stable state. Okay? But when they change from one form to another form, this is basically the reorganization, recrystallization. But there is no further change in the amount of crystal that is formed. Okay? So in the these are the facts that you have to understand. Yeah? In the exam, you may get a question like, which are the followings are true for crystallization? 1, 2, 3, 4. There is no further change in the crystalline volume phase. That is true. So you have to get the facts right. Okay, let's now look at more detail the process of crystallization from a solution. Imagine now we have a solution. We have a solute in the form of sugar. Okay, then we dissolve in water so that we get a sugar solution. So any solutes, for example sugar, will have its own solubility value. We denote this by CS in solution. Solutions with solute contents below this concentration are undersaturated and will allow further dissolution of solute crystals. Container here, a beaker or a pot. We have water. So the water here is the solvent. Any solution must have two components, solvent and solute. Yeah. The solute in this case, let's say sugar. So we add sugar. Okay. So sugar here is the solute. Each solute will have its own solubility value, meaning that the maximum amount of the solute that can dissolve in the solvent at a particular temperature. At a particular temperature. So meaning that, let's say sucrose, let's say sugar in this case is sucrose. So sucrose at, say, room temperature, our room temperature. What is the CS? How do we know? We can carry out some experiment. We can dissolve the sugar, stir it, then you can see the sugar dissolve completely, dissolve more, put more, stir, dissolve, add more, add more, add more, until one point you see that the sugar cannot dissolve anymore. So that's the point where then you know how much you have added. That is the CS. But if you repeat this experiment, increase the temperature, do you think the CS would increase or decrease? If you increase the temperature now from room temperature, to, let's say, 80 degree, do you think the CS will increase or decrease? How many say increase? Raise your hand now. How many of you say decrease? We understand the question. When you increase the temperature now, then you dissolve the sugar. Do you think the CS value would increase or decrease? So I have seen those who say increase. How many of you say decrease? How many of you is unsure? Grace, why? Why you are unsure?
Because when you dissolve like the sugar in the water, right? So the sugar molecules will bind to the water already. So I'm thinking if we increase the temperature, how can it allow the water molecules to bind to more sugar molecules?
Makes sense, but not really true. When the sugar crystal, in this case sucrose, dissolve in water, actually it doesn't bind the water molecules, but it forms a hydrogen bond, of course, with the water molecule. Sucrose and water molecule form the hydrogen bond. Yeah. But when you increase the temperature, yeah, by increasing the temperature, you are giving the system more energy. You are giving the system more energy, and this energy is required to melt the crystal, to disrupt the crystalline structure, and therefore allowing the sugar crystal, the sucrose crystal, to dissolve in solution. So the solubility value of any solutes is a function of temperature. The higher the temperature, the higher is the degree of solubility. More solute would dissolve when you increase the temperature. Less solute would dissolve when you decrease the temperature. So there is a direct relationship. Okay, so that is the CS. Now, if we carry out this experiment at many temperatures, then we can determine the CS value at each temperature. Then we can plot a graph, and this graph is called solubility curve. So we plot a graph. This one is temperature. This one is the CS, the solubility. Okay. This can be gram per 100 gram solution. percentage. Then we can get a curve. Then we can see at lower temperature and at higher temperature, the solubility is different. And any value on the curve here, the CS value on the curve here is actually the equilibrium value. The equilibrium value. The solution is in the equilibrium. Okay? Any point below the curve, the solution is in the undersaturated state. Any point below the curve, let's say here, 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 even here, the solution is in the undersaturated state. And you cannot start a crystallization process. You must get the solution into supersaturated state. How do you get? Where? Where in the curve? Where in the graph? Anywhere above the line. Anywhere above the line. Above this line. That is supersaturated state. You must get this value, we call it CSS, above the CS. You must get into the concentration, into the supersaturated state. How do you get to the supersaturated state? That we will see later. Is that clear? Please? Okay. Now, supersaturation can be expressed as the difference between the concentration of a saturated solution, CSS, and the equilibrium solubility, CEQ. In this case, CEQ is the C equal to the CS lah. Okay. So, we can express the delta C here delta C is the difference. Let's say this point here, this point is CSS, the sucrose, the solutes in the supersaturated state. Let's say we compare this with this point below the line, meaning undersaturated. So this is the CS, or we no, I'm sorry. This on the line here, so this is the CEQ, which is the CS, or the solubility value of that solute at that particular temperature. Remember, it is a function of temperature. So the difference between this is the delta C, which is the CSS minus CEQ. So you can see now, in order to induce the first step in crystallization, which is nucleation, we must get into supersaturated state. Imagine now, in this room, remember, this room is one big solution container, and we are the solutes. Okay. Now the solution is in the undersaturated state. There are many empty seats here, right? Undersaturated state. How do you want to form a crystal? Yeah. Well, we need more. We need more, so we get more people to come in. This room can accommodate maybe about 60 maybe. I don't know, is it 60? Let's bring in 1,000 people. Can this room accommodate 1,000 people? So when 1,000, maybe 1,000 too many, maybe 500 people come into this room, it becomes overcrowded. Which is equal to, the analogy is equal to supersaturated state. This room can only take maximum 100. Itu pun dah berimpit. Now we bring in 500. So we have to kick out 400. Kick them out. So when you kick them out, this is similar to when you dissolve more solutes above the CS. Let's say for sucrose at room temperature, the maximum sugar that can dissolve is 60 gram in 100 gram solution. So if you put in 61 gram, meaning this 61 minus 60, there's 1 gram that cannot dissolve. So that is what you see, the 1 gram that cannot dissolve. You can see with your eyes. Because the solution, the solvent cannot take it anymore. Just like this room can take only 100, we bring in 500. We cannot take this additional 400. We have to kick them out. Okay. So, in order to induce crystallization, to start the nucleation, we have to be somewhere above this equilibrium line. This is called equilibrium solubility curve. We have to get above that. The further you are above the line, the higher is the degree of supersaturation. Because compare if I am here, just slightly above the line, but still supersaturated. Compare if I am here, much higher than the solubility. So meaning that the driving force, daya penggerak, the driving force to start the crystallization or nucleation would be higher here compared to here. Because the delta C, the difference between this point and the equilibrium line, here small. Here, this one, here, delta C is bigger compared to delta C here, right? So these are the things that the following slides actually will explain what I have explained here. So this is a magic curve. We call it magic curve because when we talk about crystallization, and in the industry they have this graph for their system. Different system would have their own solubility curve. If you are dealing with sucrose, you need to have the solubility curve for sucrose. If you are dealing with different sugar, so you need the solubility curve for each sugar, because you want to define where is the equilibrium line, where is the undersaturated state, where is the supersaturated state, where we are, where we should be in order to get the high driving force to start the process of crystallization. So any solubility curve we plot as a function of temperature and the concentration. The concentration in this case sugar. If the salt. If it's a organic acid, it's organic acid. If a monosodium glutamate, is monosodium glutamate. Anything that is the crystallizing species, the component that will crystallize. Okay, don't ignore this line, this the yellow color and the blue line. Just look at the red line, which is this one. This is called solubility curve, or sometimes we refer it to as equilibrium solubility curve, because any point on the line is the CS, is the value of solubility of that solute in equilibrium at a specific temperature. Then we can see the line always goes up, meaning that the solubility at higher temperature is always higher than the solubility at lower temperature, meaning that when the temperature of the solution is higher, it can take more solute. Can take more solutes. So any point below the red line is called undersaturated. You cannot get crystallization below that line. Whatever you do, you cannot get crystallization. So the solution is stable. Technically, any point above the red line, the solution is technically in the supersaturated state. Any point above the red line, the solution should be technically in the supersaturated state. When the solution is in the supersaturated state, meaning that the solution is ready to undergo crystallization. Should be. But, okay, this is a big but. BUT. But, okay. But sometimes, although the solution is in the supersaturated state, sometimes we cannot get crystallization. So there is a certain condition above the solubility curve in the supersaturated state, we cannot get crystallization. Faham tak? Secara technically, when the solution is in the supersaturated state, we should be able to start the process of crystallization. But sometimes we don't get, although the solution is in the supersaturated state. So there is a certain region, satu kawasan, satu area in the solubility curve where the solution is in the supersaturated state, but it cannot, the crystallization cannot happen. So this area, the yellow color, is called metastable. It's called metastable state. Metastable state is a state where the solution is in the supersaturated but crystallization cannot start. How big is the area? It depends. It depends on many factors. It can be very small area, it can be very big area. Yeah. So we can define one region for any supersaturated solution. One region, one area where this region is called metastable. Metastable means the solution is in the supersaturated state, but crystallization cannot occur, cannot happen. So let's say the region is now the boundary between this red line and the blue line. And now above this metastable state is the solution is in the supersaturated state, but crystallization can happen spontaneously. That's the key word. In metastable state, the solution is in the supersaturated state, but crystallization cannot happen spontaneously. But in this region called labile region or unstable region, the solution is also in the supersaturated state, but crystallization can happen spontaneously. That's the difference between the labile state and the metastable state. In the metastable state, I repeat again, the solution in the supersaturated I have problem when I teach this topic. Nak sebut supersaturation. The solution is in the supersaturated state, but crystallization cannot happen spontaneously. But lagi banyak sangat but. If I add a crystal seed, benih crystal, I just take a very fine castor sugar, yang beza antara castor sugar dengan table sugar apa? Castor sugar very fine kan. So I just take a pinch of that, put that in the solution. In this solution now is in the metastable state. Okay, imagine, and we just put some crystal seed. This crystal seed now will start to grow, and crystallization start to the nucleation starts, and not nucleation, sorry, the seed crystal start to grow, and this will induce further crystallization in the metastable state. So now I repeat, in metastable state, the solution is in the supersaturated state, but crystallization cannot happen spontaneously. However, if we add the seed crystal can grow, and this will allow the solution to now crystallize. In the labile state, crystallization can occur spontaneously. You don't need to add seed crystal. It just happen once you are above the blue line, crystallization will start. It will form crystal spontaneously. So that's a keyword, spontaneously. Jelas tak? Mestilah jelas kan? Teruk saya nak explain ni. Ada soalan? The rest of the slide actually to explain about this curve. But the next thing that we want to learn now, how do I get into that supersaturated state? Okay, now you know what will happen. What will happen when we are in the supersaturated state? There are two things that can happen. The crystallization cannot happen in the metastable state. If the solution in the metastable state, crystallization cannot happen spontaneously. But if we add the seed crystal, we can get crystallization. In the labile state, we can get crystallization spontaneously without having to add seed crystal. Okay, that is clear. Now the next thing is, how do we get to that to the supersaturated state? So in point A, no crystallization. The solution is undersaturated. In point B is the metastable state. The solution is already in the supersaturated state, but no spontaneous crystallization. But again, if we add the seed crystal, we can get crystallization. In point C, is in the labile state. The supersaturated solution is in the non-equilibrium state. They want to go to the equilibrium state now. One way to get to the equilibrium state, they must crystallize. The solute must form crystal. All the thing that happen during crystallization is actually the attempt by the solution to go from the non-equilibrium state to the equilibrium state, meaning that from point C to on the red line. They want to go back from point C to the red line, because the red line is the equilibrium state. So what they can do, they must crystallize. When they crystallize, they form crystal, solid crystal, and when they form a solid crystal, a few things will happen. Yeah, well, let's see. Later we come back to this graph. So, when the solid contents exceed the solubility concentration, we get supersaturated solution. Any crystal present in a supersaturated solution will not dissolve, but rather will grow larger as the solution attempts to approach its equilibrium condition. Faham tak ayat tu? Tak faham? Any crystal present in a supersaturated solution will not dissolve. Remember, CS, katakan sucrose pada room temperature dia boleh dissolve maksimum 60 gram dalam 100 gram solution. So kita dissolve sampai 60, okay. Bila sampai 61, dia tak boleh dissolve lah because the solution is already in the supersaturated state. Itu maksudnya. Ataupun kalau kita tengok graf ni, above the red line, say point B or point C, if you dissolve, add more sugar, it won't dissolve because the solution is already in the supersaturated state. It cannot take, just like this room can take 100, you bring in 200, cannot take that additional 100. We have to kick them out. Or a better analogy is like this. This room can take 100 people. Now we bring in 200. How do we know? How do we want to accommodate 200? So we have to now, instead of sitting like this, we have to now sit very close to each other, or we have to arrange in such a way face to face, so that these 100 people now extra can come in. So just by arranging ourselves in such a manner, meaning that just like the molecules arranged in the crystal lattice to form crystal. But that's the maximum. No matter now how you arrange yourself, if you now bring another 50 people, just cannot take anymore. Just like now we add more solute, it cannot dissolve anymore in the solution. So this additional 50 people, because no matter how you arrange yourself, cannot come in. So we have to kick out. So those are what we see as the the undissolved part when we add more sugar in the solution. I hope it's not too complicated, the analogy that I give you. Yeah. So any crystal present in supersaturated solution will not dissolve, but rather it will grow larger as the solution attempts to approach the equilibrium value. As the solution attempts to approach from the supersaturated to the equilibrium value. Supersaturated solutions are necessary for the crystallization processes of nucleation and growth. So that's the prerequisite. You must have supersaturated solution. How to achieve? In 2 minutes. How to achieve supersaturation? How to go above the red line just now? Now remember, we have solution, we have melt. So let's see for solution. For solution, one way is actually quite simple. Let's say the fat. Remember, in fat we have triglycerides. Each triglycerides have its own melting point. So all we need to do to start the crystallization, we just cool the melt below the melting point of the triglycerides in the fat. But of course, in the fat, different triglycerides have different melting points. Some is higher, some is lower. So when we cool down the temperature, not all triglycerides will crystallize at the same time because they have different melting point, right? That is actually the process of fractionation in the oil industry. In our palm oil, we can cool down the liquid oil Then when the temperature reach certain range, certain fraction of the triglyceride would crystallize, and we remove this. We reduce the temperature lower, another fraction of the triglycerides in the oil would crystallize. We remove that. So we can get many different fractions. Each fraction contains triglycerides with different melting point. It's very interesting. Yeah. So cooling below the melting point of a compound. So that's sometimes we call it super cooling. For solution, producing a concentration in solution greater than some solubility concentration Cs, and this can be achieved by heating the solvent prior to dissolving the solute, so that I think no point I read this one because this one needs explanation. But this part already I have the online lecture part. So I will give you the link. Maybe some of you have found it. It's on the YouTube already, in Vimeo also. So I will give you the link and please watch those. But I will continue this on Wednesday. On Thursday.